Hello everyone, this video is about simulating gravity casting of metallic materials. Similar to other simulations, firstly we need to model our geometry in a CAD software, so I usually use SolidWorks, and today's simulation is about simulating the casting of a rectangular model. So you every time have a client and they gave you drawings, so stay committed to your drawings, but today we are going to model our geometry totally randomly. Okay, let's sketch a rectangular. I think this size would be good. I prefer 20 millimeters. Okay, let's add the runner. Okay, please note that it's very important to understand the physics of the process that you are going to simulate, so learn about what you are going to simulate before doing anything in your CAD or CAE software. Okay, now we are adding our runner. Okay, let's choose a reference geometry plane for our lofting process. But firstly we need to add this circle, and after that we could continue with the lofting process. The circle is way big, so let's decrease it to 35 or even 15. Yes, it's a better dimension. So let's start the lofting process. Okay, now we created our model, so let's create the mold. Assembly. Okay, here I insert the model and create a new part, and then we could sketch the mold from this surface with a massive rectangle and extruding downward, so everything is okay. The next part would be creating the space for our molten metal, so we go to this part and use the cavity command, and then we choose the model, and as you can see we have free up the space for our molten metal. So at this moment we need to save our files for the simulation process. Okay, here is the model step file type, and now we can suppress the model and save the mold again with a step file. Okay, now we're finished in SolidWorks, and we could start the visual cast. Okay, let's create a new file and firstly save the file in the same folder that you want to save your simulation results. Okay, let's use the visual mesh application and import the models. Okay, we also need to define the units, which could be millimeter. Okay, firstly we need to check the geometry that we have imported. There is No problem. Let's create our assembly. As you can see, here is our intersection between the model and the mold. Okay, we want to assemble it. As you can see, the color changed to pink, or I think it's magenta, so it means that you have an intersection here at this surface. Okay, the next step would be applying the surface mesh. I'm totally okay with the size of the mesh, but you can optimize your mesh size or element size in this space, and then applying the surface mesh. Okay, as you can see, the mesh is totally applied. Let's check the surface mesh. No problem, surface mesh is okay, and we could apply our volume mesh. Very nice. And now we are done in our visual mesh, so we can move to visual cast. And at the first stage, the visual cast asks us to define the gravity vector, so I'm going to use the -y vector. Everything changed to what I wanted. So next step would be creating volumes. Okay, this is our model, and this would be our mold. The type of our model is alloy, because we are going to fill this void with metallic materials, molten metal. And this would be mold, as we have mentioned. Okay, I'm going to cast an AZ magnesium alloy with an initial temperature of 615, and also I'm going to use a metallic mold with an initial temperature of 300, because I wanted the preheated mold to give time to my molten metal for the solidification process. Okay, let's apply this. Let's move to interface manager. As we have two different kind of materials, we need to change this type to coink, and also assign this interface condition, apply. And the next step would be process condition manager, which is very important to have a proper simulation process. Okay, let's create a heat type and choose the region which is external mold. I want to apply an air cooling boundary condition. I also need to have a temperature type boundary condition for my molten metal, which I'm going to use circle type, and bigger radiuses. 20 is a bit high, 18 would be enough. Okay, apply it, and the temperature would be 750, because I wanted a very good molten metal with good fluiding properties. So we also need a velocity for our molten metal, and the region would be same as our temperature. Okay, and you could use the velocity calculator. I want to fill this mold in 20 seconds, which this boundary condition calculated and applied. Okay, everything seems fine. Let's move to simulation parameters, choose the gravity filling, click OK, apply. The next part would be checking the data. There are no errors, so we need to start the simulation. Okay, let's start the simulation and then check it together. Okay, as you can see, the simulation process finished. So in this Explorer section, we can hide different parts of our simulation. So firstly, I hidden the mold part. As you can see, we are at the initial stage of our simulation. Let's see what happens. in terms of temperature. Very nice. You can see the contour. Let's slow it. As you can see, the changes in temperature of this molten metal. Let's check the fraction solid. As you can see, the simulation starts from the corners, which is true, and everything is okay. We can also check our total shrinkage porosity. Okay, do the simulation, ask your questions under this post, and follow me for upcoming tutorials. Thank you so much. Have a nice day. Bye.